Hello, good morning, everyone. Good morning to Just Get Civil. Good morning for Mission Gate 2021. We have already got the gate admit card. Hope so, everybody. तो भैया अभी जस्ट और कुछ ही दिन बाकी है तो हमारे इन्वायरमेंटल इंजीनियरिंग का टॉपिक्स तो पढ़ चुके हैं. अभी हम लोग प्रॉब्लम्स कर रहे थे जिस चैप्टर का प्रॉब्लम्स नहीं हुआ था. तो फिलहाल इन द लास्ट क्लास वी हैव डिस्कस्ड अबाउट द प्रॉब्लम्स ऑन क्वालिटी ऑफ वाटर चैप्टर. And today is the 21st lecture of this session. Before going to the lecture details, myself Soumyajit Sen, done my masters from IIT Bombay in environmental engineering, and there just a reminder कि अगर आपके पास अभी तक Unacademy learning app ना हो, so go to the Play Store and install the Unacademy learning app. Install the Unacademy learning app. And there you please click for the GATE and EAC courses and go for the plus courses and subscribe the plus course. And if you go for the plus courses, there you will get a personalized mentorship program. जहाँ पे आपको एक ऐसा कोच मिलेगा जो ऑलरेडी इस प्रोसेस से गुजर चुके हैं एंड क्लियर द गेट और EAC एग्जाम्स विद फ्लाइंग कलर्स. हमेशा जरूरी होता है कि आपका जो स्ट्रेटेजी है उसको कैसे आप मॉडिफाई कर पाओगे, क्या क्या है, क्या लेना है, ये सारी चीज के लिए. And while taking the subscription, don't forget to apply the code SEN10. Don't forget to apply the code SEN10. This is the code by which you can secure a good amount of discounts on the value mentioned here. Already started a good news for that. From 28th December 11:15 a.m. we have started a batch for GATE 2022 in for English and Hindi, both the languages. Those who are actually aspirants for GATE 2022, you can go for this batch, and while if you're subscribing this, go for the subscription and apply the code SEN10. Don't forget to apply the code SEN10, ACN10, SEN10. The new batches are there for the EAC aspirants prelims 2021. For the general studies, we have already started the class from last date yesterday. So here also you can apply the code SEN10. And again batch B, that was for the batch A, first batch. This is for the second batch, batch B. Once again you can apply the code SEN10 to secure the 10% discount. SEN10 to secure the 10% discount. Now we are going for the problems on plain sedimentation. तो हम लोग क्या बोल रहे थे कि नॉर्मली क्या हो रहा था, हम लोग प्रॉब्लम सीरीज का प्रॉब्लम्स डिस्कस कर रहे थे एंड वेयर we have already discussed about the problems on quality of water. तो हमारा चैप्टर सीक्वेंस क्या था, चैप्टर सीक्वेंस था कि we have already discussed about the problems on quality of water. हमारा चैप्टर सीक्वेंस ऐसा था कि पहले we have started with the discussion of the process of first we have discussed regarding the वाटर डिमांड एंड द पॉपुलेशन फोरकास्टिंग, जिसका प्रॉब्लम हम लोग देख कर चुके हैं, सॉल्व कर चुके हैं. Then we have gone for the in the domestic water supply part, then we have gone for the sources and conveyance of water, जिसका भी प्रॉब्लम हम लोग कर चुके हैं. Now thirdly we are going for the problems of quality of water. We have gone for that. थर्ड चैप्टर का प्रॉब्लम जो है क्वालिटी ऑफ वाटर, वो भी हम लोग हो चुका है. And that is the class that today we will solve the problem from plain sedimentation. Then from the next day onwards, like tomorrow, we will solve the problems for the coagulation and flocculation and filtration, and then the disinfection and the Now we will solve the problem of groundwater treatment. So we'll cover up this portion. We also solve the problem of distribution system if certain is left. उसके बाद वेस्ट वाटर में हम लोग काफी चीजों का प्रॉब्लम्स ऑलरेडी सॉल्व कर चुके हैं, जैसे ट्रिकलिंग फिल्टर से लेके ट्रिकलिंग फिल्टर, सेप्टिक टैंक, देन आपका स्लज डाइजेशन प्रोसेस, ऑक्सीडेशन पॉन्ड, ये सारे चीज का प्रॉब्लम्स ऑलरेडी सॉल्व है. वेस्ट वाटर का क्या है कि वेस्ट वाटर फ्लोरेट, डिजाइन ऑफ सीवेट्स और कैरेक्टरिस्टिक्स ऑफ वेस्ट वाटर और प्रिलिमिनरी ट्रीटमेंट बहुत छोटा चैप्टर है. ये सारे चीजों का प्रॉब्लम्स हमको सॉल्व करना है. आफ्टर सॉल्विंग द थिंग वी विल हैव अ स्पेशल क्लास. सारे चीज खत्म होने के बाद एक जिस्ट रहेगा, एक स्पेशल क्लास रहेगा जहाँ पे पूरा चीज का जिस्ट डिस्कस होगा, और जिस्ट डिस्कस होने के बाद उधर ही हम देखेंगे कि हाउ टू प्रोक्योर फॉर द गेट 2021 with environmental engineering. Okay, so before solving the problem of plain sedimentation, क्योंकि ये काफी पहले का क्लासेस है, आई एम जस्ट गोइंग थ्रू द रिकैप पार्ट. थोड़ा सा रिकैप कर रहा हूँ कि क्या है, क्या पढ़ चुके हैं, क्या ही देख चुके हैं फॉर दिस प्लेन सेडिमेंटेशन प्रोसेस. শোন না, চাদরটা চাদরটা এমনি হাতে কেটে নিতে হবে, এটা. So just take the design parameters. Just I'm going for a recap. यहाँ पे पहला पैरामीटर था सरफेस ओवरफ्लो रेट और एसओआर. और हाइड्रोलिक लोडिंग रेट हम लोग बताए थे क्या है ये हाइपोथेटिकल पैरामीटर, कैसे ये काम करता है. देन एसओआर का फॉर्मूला दैट इज क्यू बाय सरफेस एरिया. इट इज एक्चुअली द डिजाइन सेटलिंग वेलोसिटी एंड टैंक प्रॉपर्टी ऑफ द, इट इज नॉट अ पार्टिकल प्रॉपर्टी, इट्स एक्चुअली अ टैंक प्रॉपर्टी. आप लोग याद होंगे. जस्ट गो थ्रू दिस थिंग, गो थ्रू द स्लाइड्स वन. आई एम जस्ट गिविंग यू सर्टेन टाइम, आई विल गो फॉर द प्रॉब्लम्स. Where the particle settling velocity, if it is more than the design settling velocity, obvious settle. If it is equals to the design settling velocity, just settle. And if it is less than, particle will escape. Then Jensen time, which is actually V by Q. And for volume, for rectangular tank, it will be like L into B into H. For the radial tank, you need to go for this particular formulation process where V radial is d square into 0.011 d plus 0.785 into H. Then the flow through velocity or horizontal flow velocity by the velocity which water is flowing from inlet to outlet, defined by VH is equals to L by dt, and VH will be equals to Q by cross-sectional area, where cross-sectional area is B into H, and VH will be in between 0.15 to 0.9 meter per minute. Ideal value 0.3 meter per minute. The detention time L by VH, detention time is H by V naught. So from there, this is the equation it is denoted. L by H is equals to VH by V naught. All things are explained. You can go through the plane sedimentation lecture. There we will show that how the things are coming. All the explanation will be there. अभी आ रहा है आपका वेयर लोडिंग रेट में हम लोग देख चुके हैं, दैट इज वेयर इफ लेंथ इज नॉट प्रोवाइडेड देन दैट इज द थिंग. Particle removal efficiency defined by eta. So from here, this is that what is the relationship between the surface area and the efficiency. And different particles are having different efficiency, so eventually the total efficiency part. And once again, we have discussed about the cowering of particle. और एक चीज आपको है कि V naught or SOR or design settling velocity is equal to the settling velocity of that particle whose diameter is minimum to get 100% settlement in the water. ये चीज हम लोग डिटेल्स में डिस्कस कर चुके हैं. Hope you remember. If not, then please go to the plane sedimentation lecture once. Then you can solve these questions. And what is displacement efficiency? Everything is discussed, and then we are going for the problem. The first problem. Have a look. Sedimentation tank. (6 meter wide and 50-meter long and 3-meter water depth) is treating 2 mld of water. Find the surface overflow rate. All the questions what we are going to discuss is of the same thing what we can expect in our examination process. Just have a look. So it is given B is equals to 6 meter, L is 15 meter, and H is 3 meter. Q is given as 2 mld. Asking for what? Asking for surface overflow rate. So SOR is nothing but Q by surface area. But Q will be as 2 mld, so it is nothing but 2 into 10 to the power 6 liter per day by surface area is 6 into 15. But as they're asking in hour, you need see hour. So it will be 2 into 10 to the power 6 by 6 into 15 into 24 liter per hour meter square. The final answer will be 926 liter per hour meter square. Option B will be your correct answer. Option B will be your correct answer. Hope you understand the thing. Option B will be your correct answer. Next question. Have a look. A plain sedimentation tank 6 meter wide, 15 meter long, and 3 meter water depth is treating 2 mld of water. Find the retention time. Have a look. So let's solve the question. 6 meter wide, B is 6 meter, length is 15 meter, and depth is 3 meter, right? Once again, Q is equals to 2 mld. The retention time they're asking all the options are in hours, so we need to find out in hour itself. The retention time is nothing but V by Q. Where volume is rectangular sedimentation tank, so L into P into H. That part we will give in meter cube. By Q, we need to find out in meter cube per hour. Then only you can get the hour answer. So 86 into 15 into 3. That much meter cube is there. By Q is 2 mld, so 2 into 10 to the power 3 meter cube per hour day. It's 24. Final answer will be 3.24 hours. So option D will be your correct answer. Option D will be your correct answer. 3.24 hours. Option D will be your correct answer. Now, you have seen that the things actually happening with the process of unit conversion itself. Question number 3. Question number 3. Let's have a look. A rectangular sedimentation tank is treating a 1.8 mld of raw water with a detention period of 4 hours. The volume of the tank required is. Its cubic quantity 1.8 mld, as all are asking in meter cube. So 10 to the power 3 coming as 300 meter cube. Option C will be your correct answer. Option C will be your correct answer. I'm going for question number 4. A sedimentation tank is to be designed to treat 1 lakh cubic meter of water per day. If the settling velocity of the particles to be removed is 20 meter per day, then the area of the tank required is. Quickly solve it. Have a look and solve it. A sedimentation tank is to be designed to treat 1 lakh cubic meter of water per day. ডাকা ভাই দরকার to treat 1 lakh cubic meter of water per day if the settling velocity of the particles to be removed is 20 meter per day, then the area of the tank required is. আর্জেন্ট দিচ্ছে আমার ক্যালকুলেটরটাতে ক্যালকুলেটরটা ফোন করছি দেখতে পাস মেসেজ করলি আই উইল কল রাইট ব্যাক দেখবি দেখ এতক্ষণ ধরে ওয়েটিং এ আছে Sedimentation tank is to be designed to treat 1 lakh cubic meter of water per day if the settling velocity of the particles to be removed is 20 meter per day, then the area of the tank required is. So Q is actually given as 1 lakh meter cube per day. Settling velocity of the particle removed is, so here it is V naught 20 meter per day. So surface area obviously it's Q by V naught, which is 1 lakh by 20 meter square. It's 5,000 meter square. Very basic problems these are. We'll solve some hard problem also. Next, question number 5 and 6, common data question. Question number 5 and 6, common data question. Have a look. Try to solve this question. A settling tank has 26 meter in dia with a 2.10 meter side water depth. Effluent weir is located on the periphery of the tank for a water flow of 13,000 meter cube per day. The detention time is available is and the well loading is. So let's solve it. So settling tank dia is given 26 meter. Side water depth H is 2.10 meter, and Q is given as 13,000 meter cube per day. Volume of radial tank. I have already told you that when you need to find out the volume of radial tank, you have to go with this particular formula. If you remember this one, d square into point 011 d plus 0.785 into h. From here you have to calculate the volume, and as distance and time is nothing but volume by q, you will find the answer as 2.41 hours. Option A will be your correct answer. And that is for question number 5. For question number 6, we are loading rate WLR is, as the length of wear is not provided, so क्या होगा, formula Q by pi into D. So from here you will get find it as 159 meter cube per day meter. Hope it is clear to you. Just have a look. Next question. Also a GATE 2015 question. In a wastewater treatment plant, primary sedimentation tank designed at an overflow rate of so SOR is given as 32.5 meter cube per day meter square. Length is given as 32.5 meter, width is 8 meter, and liquid depth is 2.25 meter, and length of weir is also given as 75 meter. Asking the weir loading rate WLR is nothing but Q by length of weir. Now here Q is not provided, but SOR into surface area, that will be Q by length. SOR is 32.5. Surface area is L into B, 32.5 into 8 whole by 75 will be equals to 112.66 meter cube per day meter. 112.66. Okay, hope you understand this question. Question number 8. Question number 8. An ideal settling basin has a plan area of 100 meter square. If a flow of 2400 meter cube per day has passed through the basin, then for removing the discrete particle completely from the basin, the terminal settling velocity is nearly. Question number 8, please. So here for the eighth question, an ideal settling basin has a plan area of 100 meters square. Flow of 2400 meter cube per day. Then for removing the discrete particle completely from the basin, the terminal settling velocity is. So nothing else is there. Cube by surface area. It's 100 meters square. Sorry, 2400 meter cube per day by 24 into 100. It's 1 meter per hour. It's also a great question. Question number 9. Very important type of question it is. Question number 9. The horizontal flow sedimentation tank is treating water containing 10%, 60%, and 30% of the particle having the settling velocity 0.1, 0.2, and 1 mm per second, respectively. What will be the total percentage of particle removed if the SOR is having 43.2 meter cube per meter square day? Please look at this question. So, things are so particle, first particle, second particle, and third particle. Percentage is 10%, 60%, and 30% of the particle having settling velocity .1 millimeter per second, 0.2 millimeter per second, and 1 mm per second. The settling velocity of particle. Now, SOR is given as 43.2 meter cube per meter square day. Our first job is to convert that into mm per second because every settling velocity is in mm per second. So it's meter per day. So it's 43.2 into 1000 mm per by 24 into 3600. It will be 0.5 mm per second. Now the efficiency for the first particle will be 0.1 by 0.5 into 100. It's 20%. Efficiency of second particle will be 0.2 by 0.5 into 100 is equals to 40%. And efficiency of the third particle will be obviously 1 by 0.5 into 100. Theoretically, it's more than 100%, which is not possible. So it will take it as 100% itself. Okay. Now, like গরম করতে হবে। So overall efficiency will be what? Summation of I equals to 1 to n eta I. That will be equals to mic টা বন্ধ করে 10% of the particle is having 20% efficiency plus plus 60% of the particle is having 40% efficiency and 30% of the particle is having 100% efficiency, right? So it is 2 plus 24 plus 30. Overall efficiency will be 56%. Overall efficiency will be 56%. Overall efficiency will be 56%. Now, question number 10 and 11. So, if you hope you understand this problem, number 9. Have a look. Question number 9. Question number 10 and 11. It's a gate question you've already solved actually. 2.41 hours and 159 will be the answer. We have already solved it. Next, solve certain more questions are there. Let me write down the questions. Some gate questions also there. Gate 2019 question is there. Let me write down the questions. Question number 12. An ideal settling basin is designed with surface overflow rate of, or let me write down. কালকে ছবিগুলো কোথায়? তোলা ছবিগুলো কোথায় ওগুলো? পরে কেনা। So an ideal settling basin is designed with SOR of 1 meter cube per meter square hour Particles have their discrete settling velocities and concentration as follows. Four type of particles are given with the settling velocities and the initial concentration is given. What will be the correct estimate of overall removal of particle concentration? That is a problem. If you have understood the question number 9, then you can easily solve this question number 12. Please solve this question number 12. Then we'll discuss later the other questions. Question number 12. Please solve this question. So let's solve the question. So once again, number, settling velocity of particle, and the efficiency is a point of concern. There are four particles are there. Settling velocity of particle is given as 1 meter per hour. It is given as 0.5 meter per hour, 0.1 meter per hour, 0.05 meter per hour, right? So now efficiency given as efficiency 1 will be SOR is also given as 1 meter per hour. 1 meter cube per meter square hour. It's 1 meter per hour. So efficiency 1 by 1 into 100, it's 100%. For the second particle, it is 0.5 by 1 into 100, it's 50%. For the third particle, it is so this particle will be removed 100% में this particle का जो सारे concentration है वो remove हो जाएंगे 100 मिलीग्राम पर लीटर. इसका होगा 50 मिलीग्राम पर लीटर, इसका होगा 10 मिलीग्राम पर लीटर और इसका होगा 5 मिलीग्राम पर लीटर. तो कुल मिला के आपके पास रहेंगे 165 मिलीग्राम पर लीटर. That is the overall efficiency, overall particle removal concentration. 165 milligram per liter. Okay. That is question number 12. Now we're going for question number 13. Hope you understand question number 12. This is GATE 2019 question number 12. Now going for question number 13. GATE 2018. Very easy question. The total volume of a primary settling tank is 2500 meter cube and the wastewater flow rate is 25 into 10 to the power 6 liter per day. The detention time will be 4 options are given: 10 by 24 hour, option B 24 by 10 hour, option C 24 hour, option D 1 by 24 hour. Quickly solve this. I don't look করতে দিয়ে I don't instant নিয়ে যা বেরো এখন So the total volume of primary settling tank is 2500 meter cube and the wastewater flow rate is this. Detention time. Quickly you can solve. V is 2500 meter cube. Flow rate liter per day. V by Q. As asking in hours, 24 by 10 hours. Option B will be the right answer. Option B will be the right answer. Option B will be the right answer. 24 by 10 hours. Now we are going for question number 14. Question number 14. It's also a GATE 2010 question. So be careful about the statement, because when you are talking about the GATE question, आपको हमेशा उसका स्टेटमेंट और उसके हिसाब से उसका सॉल्यूशन जैसे होगा उसका ऑप्शंस आपको देखना पड़ेगा, क्योंकि समटाइम्स यू मे रिक्वायर डिफरेंट यूनिट्स. कभी कभार हो सकता है कि आपका स्टेटमेंट के अंदर ही उसका सॉल्यूशन छुपा हुआ है. दैट थिंग यू हैव टू बी वेरी स्मार्ट इन गेट. ऑलवेज यू रिमेंबर, यहाँ पे जो खेलना है, जो पढ़ाई है, जो भी है, सब कुछ है स्मार्ट प्ले, not very hard play. You have to be very smart when you're talking about a GATE examination. The question is, in a continuous flow settling tank, 3 meter deep and 60-meter long, what flow velocity will you recommend for effective removal of 0.025 mm particles? The specific gravity is 2.65. New coefficient of kinematic viscosity is 0.01 centimeter square per second. Solve this. Question number 14. Let's solve the question. H is 3 meter, length is 60 meter. What flow velocity will you recommend for effective removal? Here, effective removal means 100% removal. Now, what is the removal part? That means 100% किसका रिमूव होता है? जिसका diameter is the minimum to get removed from the water. ये fallacy, ये सारे चीज हम लोग पढ़ चुके हैं ऑलरेडी. तो क्या होगा? We know that L by H is equal to VH by V naught. L is given, H is given, asking for VH. लेकिन हमको निकालना भी है कि V naught क्या है? V naught is the design settling velocity or is what? So V naught is actually the Vs of those particles which will be removed just 100%. Okay, so let's find out the settling velocity of particle. It will be V naught is equals to, particle is given 0.025 mm, so it's 1 by 18 into 9.81 g into dp square, 0.025 into 10 to the power minus 3 square by mu. So nu is given as 0.01 centimeter square. We are converting meter square 10 to the power minus 4. From here you will get the V naught value, right? So what will be your VH? It's L by H into V naught. It's 60 by 3 into V naught. And your VH from here you can get the value as 0.0112 meter per second. Hope you understand the solution. 0.0112 meter per second will be your final answer. Clear? Now we are going for question number 15. Question number 15. A rectangular Question number 15. Get 2009 rectangular sedimentation tank is treating 1.8 mld of raw water with a retention period of 4 hours. If the allowable SOR is 500 liter per hour meter square and L is to be given as 4:1, then the length of the tank will be, find out. Question number 15. Question number 15. The rectangular sedimentation tank is treating 1.8 mld of raw water. So let's solve this question. So Q is given as 1.8 mld, 1.8 into 10 to the power 6 liter per day. Retention period is 4 hours. SOR is given, L is to B is given. So surface, first we find out the surface area. That is Q by SOR. That is equals to Q is 1.8 into 10 to the power 6 liter per day by SOR is 500 liter per hour per meter square, so into 24. That much meter square. We'll get the value as 150 meter square. L is to be given as 4:1. So 4b square is equal to 150. From here, b square will be equals to 150 37.5. So B will be equals to 6.12 meter. So what will be your L? Is 24.5 meter. It's 24.5 meter. That is question number 15. Now we are going for question number 16. An ideal horizontal flow settling basin is 3 meter deep and having surface area of 900 meters square. Water flows at a rate of 8,000 meter cube per day. Where dynamic viscosity coefficient is 10 to the power minus 3 kg per meter second provided, and density of water is also provided as 1000 kg per meter cube. What percentage of particle will be removed? Diameter of particle given as 0.01 mm, and specific gravity of particle is also given as 2.65. It is GATE 2003 question. GATE 2003. Solve it. Question number 16. GATE 2003 question. Question number 16. So what to do? First, we need to calculate the SOR, that is equal to V naught, which is nothing but Q by surface area, right? Q is given as 8,000 meter cube per day by 900 meter square. It will be in 80 by 9 meter per day. But as we are going to find out the settling velocity in meter per second, so it will be 80 by 9 into 24 into 3600 meter per second. Now settling velocity of particle will be equals to 9.81 by 18 into 0.01 into the minus 3 whole square by, it will be 10 to the power minus 3 into the power minus 3, because then only you are going to get this mu by rho w. That's why I am writing this nu. From here you get the value of Vs. So efficiency will be equal to Vs by V naught into 100. If you put the values what you have already estimated, you should get the answer as 87.5%. You should get the answer as 87.5%. Okay. So that is the all the major types of problem of plane sedimentation is discussed here. Now, just so in this class we have discussed about certain recap of plane sedimentation, and then we have gone for the problems of plane sedimentation. Plane sedimentation is now completely over. So just to give you a reminder that if you don't have the Unacademy learning app, go to your Play Store and install that. Go for the Get an EAC Plus courses, where you will get the personalized mentorship program. And don't forget to apply while taking the subscription. Don't forget to apply the code SEN10. While taking the subscription, don't forget to apply the code SEN10. Already to 2020-22 ka batch has been launched on 28th December. All again, I'm telling you, don't forget to apply the code SEN10. Some new batches are also being announced from for General Studies Batch A 11 Jan and Batch B 11 from the same date. We have started yesterday. For both the cases, don't forget to apply the code SEN10. For both the cases, don't forget to apply the code SEN10. That is there. We will meet tomorrow with the problems of coagulation, flocculation, and filtration both. We'll meet tomorrow with the problems of coagulation, flocculation both. So we are here to complete within few days. We will complete this whole subject and will bang on target for this 10 to 12 marks in the GATE examination process. Thank you. Goodbye for today.